kids, we're going to do a quick experiment today, and we're going to go through the steps of the scientific method. And just here at the beginning, I wanted to real quick go over the steps of the scientific method, and then we'll discuss each one of these steps as we actually do our experiment. So before you start an experiment, the first thing that you always want to do is ask a question. The question is going to be something, what are you seeking to understand, or what are you seeking to find out by doing this experiment? And we kind of do this every day. Every time we say, hey, what will happen if? And so that's usually how a question will start out when you're doing some kind of an experiment. The second thing you're going to do is you're going to do some sort of background research. And if you've ever wondered what would happen if you mixed baking soda and vinegar, well, if you go online and you read anything about mixing baking soda and vinegar, you'll find that you can make a volcano, or different things happen when you mix those two things. That's actually background research. Now, background research doesn't have to be a big, long research paper. It's just going and finding out what somebody else already knows about that particular question. The next thing you're going to do is form a hypothesis. So after you ask a question, typically you say, well, I think that this will happen if I do this. So I think that something will happen as a result of the experiment or what it is that I'm trying to test. Step number 4 is actually doing the experiment itself. It's what you actually, when you are testing your hypothesis to find out what happens. So if you were to test and see what happens when you mix baking soda and vinegar, when you do that, that is your experiment. While you're conducting your experiment, typically you observe what's going on, you see what's happening during the process of your experiment, and you will collect your data. Once you collect your data, you just analyze the results. You look at the data. If you have something that you've measured or some other kind of information that you collected, you analyze it to figure out, okay, well, this is the result, and you're able to communicate what happens as a result of your experiment. And that's the last step, is communicate your findings. And we're going to do that through a video today. So I'm going to turn the camera around here, and I've got my little helper back here in the background. And we're going to do a pretty simple experiment. We're going to go through the steps of the scientific method. Okay, so we're going to, we have an experiment that has already been done before, but it's okay. We're going to test it out and see if it actually works. And this experiment is called expanding balloons. So what we're going to try to find out is that when you mix vinegar and baking soda, we know that it makes bubbles and it fizzes up and you can make a volcano. But what we might not necessarily know is why. So our question is going to be, why does a balloon expand if we mix baking soda and vinegar inside the balloon? Or in this case, we're going to mix it in a little test tube. So we've got our little test tube kit here. And we're going to follow our procedures exactly as they are written. And with any good experiment, you need your safety equipment. So I need my goggles. I need my goggles because I don't want this splashing up in my eyes. And we're going to try to be very safe. So you put your goggles on. I'm going to let her be the safe one, okay? She's going to demonstrate my safety. And typically we need gloves. So do you have your gloves? So if you could, go grab your gloves. And, okay, go get them quick. So she's going to get her gloves because she's going to be working with different chemicals, and we don't want it to irritate our hands. We need baking soda, which is what we have right here. And we need vinegar, which is what we have right here in this little cup. It says we need a measuring spoon, a funnel, and a balloon. So here is all of our equipment. We need to make sure we gather all of our materials before we get started to make sure that we have everything right here in one place. And we want to also make sure we always start with a nice clean area. Okay, so anytime you do an experiment, the best thing to do is start with a nice clean area to make sure your items don't get cross-contaminated. And right now I'm not able to find my little measuring spoon, but I have my pipette and I have my measuring cup, so that'll be okay. So our first thing, okay, we have a technical difficulty here. We have some broken goggles. Okay. Let let me fix our goggles because we need to make sure our safety equipment is properly working. And we need to wear gloves. And if we're working with other kind of corrosive chemicals or anything like that, depending on what we're doing, we may also need to wear an apron or a splatter mask, but we're not going to do that today. We're just working with baking soda and vinegar. Okay? So I'm going to let my lab assistant demonstrate my protective equipment, your safety. There's her goggles. Okay? She's getting her gloves on so that she doesn't get anything on her hands. Okay, and so when you're ready, I'm going to move this one out of the way. Alright, so I'm going to let you have the baking soda, or that's the vinegar actually. We've got our little test tube. So what we need to put in here, it says put 1 measuring spoonful of baking soda inside a balloon. Okay, so we need to start out with that. And we don't have our little measuring spoon. Actually,
there's a measuring cup
right here. It's a good thing we're in the kitchen. So it says put 1 measuring spoonful of baking soda inside the balloon. So that's what we're going to start out. We're going to put that down into the balloon. And that's all the baking soda that we need. Next, we need to place the funnel in the balloon over the opening. Okay, well, we already have that there. And this actually says that we're going to put the vinegar inside the balloon, but we're not going to do that because you can't see it as good. So we're going to put it over the end of our little test tube. And so what she's doing is she's putting some vinegar into the test tube. Yeah, maybe just a little bit more. It says we need to put 10 milliliters, so that's 2 pipettes full. And then we're going to remove the funnel. We need to put our balloon over the top of the test tube. So I'm going to do that, making sure that we don't get the baking soda into the balloon yet, because we don't need that. Okay? And for this experiment, we're going to need some tape, because what we did it earlier, and we learned that the best thing is we need to tape our balloon. Otherwise, the gas kind of escapes, and we don't really want that. So, I think we'll be okay. I'll hold on to it.
Yeah.
Okay. So sometimes you need to improvise, and that's okay. All right, so now that we have everything set up, let's go through the steps of the scientific method. Okay, first, we ask the question, why does a balloon expand? Or how do we know that a gas is being released when you mix baking soda and vinegar? Okay, how do we know that? Well, our background research told us that if you mix a base and an acid, what happens when you mix a base and an acid?
It will make a gas.
It'll make a gas. Do you remember what kind of gas?
Carbon dioxide.
It will release carbon dioxide because the chemical name for baking soda is sodium bicarbonate. So when you mix it with vinegar, which is an acid, it will actually release carbon dioxide. Okay, so we've already done that research. So what if we form a hypothesis? What is your hypothesis going to be when we mix these two together? Hypothesis?
Is going to be how does...
So our hypothesis isn't a question, it's a statement. You're going to say, I think that...
Oh, I think that the balloon is going to expand.
Expand? Do you think it's going to expand a lot or just a little?
A little.
Just a little? Okay. All right, so now we're going to test that experiment. So I'm going to hold on to it as best I can. And since you have the gloves on, I'm going to let you pick up the balloon and mix it with the vinegar that's inside the test tube. Okay? So I hear fizzing going on. What is that a good indicator? What's happening?
Can I say it?
Sure, tell them.
Okay, it is fart. The first step of fart is fizzes.
And what does that indicate? What's happening right now?
It is a chemical change.
A chemical change. So a chemical change is happening because like you said, the acronym FART, the first one is it fizzes. What might be another good indicator? If we were to look at it right now, what's happening inside there?
It's changing. I guess.
It is changing, but what do we see in there?
Bubbles.
Bubbles. We see some bubbles. All right. So you might be able to see some bubbles. Bubbles are a good indication of a chemical change, and it's starting to leak out just a little bit. So the fact that this balloon expanded and it blew up just a little bit, what happened? What caused that?
A gas.
A gas, and what was that gas?
Carbon dioxide.
Carbon dioxide. Okay, so we observed, we watched that balloon blow up right before our eyes, didn't we? And we're going to collect some data. So that balloon went from being flat to, let's see, how big is it now? Where's our little...
I had it.
Here it is. Let's measure it with our ruler. How big is it now? It's different now, I think, than the last time we did it.
Maybe.
Oh yeah, this one's about 2 inches. This one's all the way up about 2 inches in diameter.
The last time we did it was a half of diameter.
It was 1.5. Yep.
Yeah.
So the last time when we collected our results, when we did it, the balloon only expanded to about 1.5 inches in diameter. Okay? All right, so we're going to analyze our results. We know that the balloon went from being completely flat to being about 2 inches in diameter. Why do you think that happened?
Because a gas made the balloon expand.
Right. Because the gas filled the balloon, and when you put gas inside of an object, it takes the shape of the object that it's in, and it caused it to expand just a little. So, kind of, there we go.
It's just a ball.
All right. And then the last step, communicate our findings. That's just what we're doing here. When you make a video or you record it and you explain your findings to somebody else, that is your way of communicating your findings or your results. Okay? So in this case, was our hypothesis correct?
Yes.
Okay? Do you remember what our hypothesis was?
How?
No, it wasn't a question, so it was,
I
I think that,
the balloon is going to expand
because, why?
because the carbon dioxide.
Because of the carbon dioxide. Okay, so yes, we confirmed our hypothesis, so that was a good one. We did confirm our hypothesis, and we discovered that when you mix baking soda and vinegar, it releases a gas. Okay? All right, so my assistant is going to end this video, and I hope you enjoyed it and can kind of see how we went through all the steps of the scientific method. Have a good day.